Howdy and good day, fellas. We are continuing through algebra, solving more systems of equations. As promised, this objective starts out the same as CO38. I can solve a system of equations, but what's different now is the method that we're going to use. It's called substitution. And substitution works well when the equations that you're given aren't really graphable that cleanly. If they're not in slope-intercept form, if putting them into slope-intercept form is going to give you a lot of fractions to work with, sometimes it's not very clean. Or if you don't carry around a coordinate plane with you, or don't wear shirts that have coordinate planes on them, so you can graph anytime, anywhere like I do, then you might be stuck. Okay, so substitution is another method here. And the substitution method is replacing a variable with an expression. At its core, that's what we're going to be doing, replacing a variable with an expression. Okay? I'm going to scroll down. You saw here on the page, you have like most of the page to work. You know, when I leave you that much space to work, it's going to be fun, right? It's going to be good. So I'm going to scroll down so I have just as much space to work here. So everyone have this definition written? Okay. All right. So let's go. What? You said, oh, I'm sorry. I didn't hear you say that. Oh, there you go. Okay. So this first one here. Y equals 3x plus 2 and x plus 2y equals 11. Given this as a system, remember we're looking for the ordered pair that works in both of them. Do we know what x is? Or have a value for x? No. Do we know what y is? Or have a value for y? Yes, we do. That first equation tells us that y is equal to 3x plus 2. Okay, and remember our definition of substitution, kind of our process, was we'll be replacing a variable with an expression. If y is equal to 3x plus 2, then what can we do to the y variable in our other equation? Noah? Replace it with 3x plus 2. Because the equal sign meaning the same as, it means that y and 3x plus 2, they're interchangeable, right? They're the same thing. So in our second equation, we're going to rewrite this to be x plus 2, but instead of y, we're going to insert or substitute 3x plus 2. And that equals 11. Okay? So nothing changed in our second equation other than us replacing the y variable with the expression 3x plus 2, because we're told that those two things are the same. And why is this beneficial to us? What did this just give us? Elise? It gave us one equation with one variable to solve for. And we know how to do that, right? We see parentheses, so we're going to distribute first. That gives us x plus 6x plus 4. 2 times 3x, 6x. 2 times 2 is 4. Now what? What's our next step in solving this equation? Yeah. Combine like terms. X and 6x gives us 7x. We're not going to use opposite operations there, right? Because we aren't moving an x term to the opposite side. We're just combining them on the same side. So we have 7x plus 4 equals 11. What does x equal? Brent? 1. There you go. Okay. Is that it? Well, no, because we have to solve for y too. But now that we know that x is 1, where do we go from here? Gabby? Yeah, remember one of our equations says y is equal to 3x plus 2. Now that we know that x is 1, we know that y is equal to 3 times 1 plus 2, or y is equal to 5. Okay? And kind of tying this back in with CO38, graphing yesterday, if we were to graph these equations, which actually these are pretty graphable, but I wanted to start kind of easy here. But with these equations, where would they cross on the coordinate plane? Lauren? 1, 5, right? This solution represents on the coordinate plane where these lines would intersect. The hardest part, honestly, with the substitution here is where to start, and what you're looking for to start this is which variable do I already have an expression for? Here it was y equals 3x plus 2. Knowing that y and 3x plus 2 are the same thing, they're interchangeable. Those of you taking geometry, this kind of goes with our substitution property that we've talked about before. If two things are the same, you can substitute them in. Okay, and that's kind of what we're doing here. Right? Questions on this? You've seen all of one example. How are we feeling overall? Good. Okay. Medium, that's okay. You've seen one of them, right? Don't expect perfection after one. Let's go to the second one here. X equals 2y minus 6. Which variable do we have a value for? Brent? X. X is the same as 2y minus 6. So in that second equation, I'm going to do that in red actually. So in that second equation, if x is equal to 2y minus 6, I'm going to replace that x variable with 2y minus 6. They're the same thing. So my second equation now becomes 4 instead of times x times 2y minus 6 plus 6y equals 4. Okay. And once you get this equation, that one equation with one variable to solve for, it's just the algebra. It's kind of all the way back to PO10, where we had multi-step equations with parentheses, combined like terms, all that sort of stuff. Okay. The algebra here is going to have us distribute in the 4. 4 times 2y is 8y. 4 times negative 6 is a negative 24. And then plus 6y equals positive 4. Next step is to combine like terms. We have 8y is here, 6y is there. All told, that's 14 of them. 14y minus 24 is 4. Again, I'm not using opposite operations yet, because we haven't moved anything to the other side up until now. Because to solve this two-step equation, add 24 to both sides. To move it over, cancel it out from the left. 14y is 28. Then divide both sides by 14, and we get y equals 2. Okay? Taking that 2, we go back to our original equation, x equals 2y minus 6, and now that we have a value for y, we can rewrite this to be x equals 2 times 2 minus 6. And what's our value for x? Negative 2. Okay? For those of you who like to check your work, which I recommend that you do, since we use the top equation to get that negative 2, we really only need to test it in the bottom equation. And if that one works, then we can be confident that we've got our correct solution here. So 4 times negative 2 plus 6 times 2 equals 4, just replacing x and y with the variables that we got there. Does negative 8 plus 12 equal positive 4? Yes. So it checks out, and we're good to go. Okay? That third one, 3x plus y equals negative 7, how is this one different than the first two? Josh? Yeah, both equations are in standard form, which means that we don't have a variable by itself. Like in the first one, we had y by itself. The second one, we had x by itself. Is that a minor problem or a big problem in the third one? Minor problem. Okay. If something isn't the way we want it, the nice part about math is we can get it the way we want it. And back a couple objectives ago, 24 or something like that, when we converted from standard form to slope-intercept form, this is kind of why. Right, so we know how to handle this here. all we're going to need to do, well, first of all, is it going to be more beneficial for us to isolate x in that top equation or isolate y? And what I mean by isolate, are we going to want to get y equals something or x equals something? Which one's going to be better off for us, Audrey? Y equals something. Why? Right. It's got a coefficient of just 1. Okay. Could we get x by itself and go that route? We could, but we're going to be dealing with fractions or decimals. Things might get kind of messy. Okay. So I had a student a few years ago who, after I said that, said you could do it, but it was just going to be harder. Decided that just out of spite, he was going to always do it that way, always do it the more complicated way, just because I said it would be easier to do it the other way. Whatever, it's fine. Okay, you will get the same answer, but it's a lot easier starting with 3x plus y equals -7 to move that -3x over by using opposite operations and getting y by itself. Y equals -3x minus 7. Just put it into, in this case, slope intercept form so that we can get that variable isolated, right? And then from there, now that we have an expression for y is equal to -3x minus 7, we're going to replace the y variable in the second equation with that expression. So we're going to get -2x plus 4, but instead of y, we've got -3x minus 7, and all of that equals 0. Okay. I'd like you to take it from here, solve it out. I'm going to pause the video, and we'll come back and talk about things in a few minutes. All right, we went through the work for that third one there. We came up with -2, -1 as our values for x and y. And we basically talked about how there are two pieces to solving this. There's how to start, which is the actual substitution method, the skill or the process. And then there's the algebra. All right. So if you're getting the substitution part right, but the wrong answer, then it's something in the algebra. If you're not getting this equation, -2x plus 4 times -3x minus 7 equals 0, then it's something with that how to start part. Okay. Well, let's look at the back side. One that you would like to tackle together. What do you think? We've got 6 of them here. Yes, Alex. The second one. X minus 3y equals -10, and 5x plus 3y equals 4. So which variable, we've kind of got 4 options, 2 x's and 2 y's here. Which variable is going to be most beneficial to us or most efficient to us to isolate? On the second one, yes. The x in the first or the second equation? There are people screaming outside. Which x? Because we have 2 of them. The top one, okay? So we've got this x minus 3y equals -10, okay? And it's going to be most beneficial to us to get the x variable by itself because that's the variable that has a coefficient of 1, okay? Which is going to eliminate us from having fractions or decimals, at least at the start, right? So we're going to add 3y to both sides using opposite operations here, and that gives us x equals 3y plus 10. Okay? And if x is the same as 3y plus 10, here's the substitution method here. If x is the same as 3y plus 10, that means we can substitute 3y plus 10 in for x in the other equation. Because if those two things are equal, they're interchangeable. Okay? So our second equation becomes 5. Instead of x, we're putting 3y plus 10, and then plus 3y equals 4. And we like where we're at, okay, because we have one equation with one variable to solve for now. Okay? So into our parentheses goes the 5. 15y plus 50 plus 3y equals 4. Combine like terms, 15y and 3y is 18y, and not using opposite operations. Plus 50 equals 4. Oh, I see why you're upset with me. Yeah. I bet that 4 was in my head supposed to be a 2. But we can solve this. We can do it. We can do it. Subtract 50 from both sides. 18y equals negative 46. Either that, it was supposed to be 2, or I was mad at the class that I wrote this for, because that happens sometimes. And so I'll give them fractions just out of spite. Yeah. Oh, that's what went wrong. Ah. See, there's me. Wow. You see how easy it is just to completely derail an entire question? Like what someone pointed out, thank you, whoever that was that Daniel, thank you. My original equation here had a negative 10, but when I rewrote it, moving that 3y over, I wrote a positive 10 instead of a negative 10, and that derailed everything. It doesn't take much in a multi-step question such as this. It really does not take much to just throw the whole thing off. Okay, so thank you for pointing that out like 5 steps later, but still appreciate it. Okay, so let's start over again. So we are putting that. Oh no, what? We are putting that x equals 3y minus 10 in for our y variable, x variable. And so we have y times 5. This is not going to be posted. We have 5 times 3y minus 10 plus 3y equals 4. And I think this is going to work out more evenly now, yes? I believe it does. Because that gives us a 15y minus 50 plus 3y equals 4, which still gives us that 18y. But now when we move that 50 over, instead of subtracting it to get a negative 46, we're going to be adding it, and that gives us 18y equals 54, which does work out evenly. Brent, did you make the same mistake when you were? Yeah. Yeah.
We all make mistakes.
We all make mistakes. Me? Why? What? Oh, a different question. Oh.
You are just so mean.
Like I said, I must have been crabby. They must have, I don't know, irked me.
You do one more.
And so we're not done yet with this one though, because y is 3. We still need to solve for x. So we go back to any of the 3 equations that we have up at the top. We have our original 2 or the one that we manipulated. I'm going to go with the one that we manipulated because it already has x by itself. So x equals 3 times y minus 10. Now that we know that y is 3, it's going to be x equals 3 times 3 minus 10, which gives us a negative 1. Okay. All right. Noah, you accused me of being mean. Which one do you want to talk about? The last one? Okay. So, what's the scoop on this last one here?
The extra y variable is.
I have no clue. It's blank.
Okay. What is different about this one than all the others that we've talked about? Evan? Both are in standard form. Not so much that. We've had both in standard form before.
Both variables have coefficients.
Every variable, all 4 of them, have a coefficient other than 1. Okay, which means that we're just gonna have to maybe do a little bit extra work here. Okay, what do you suggest? What happens? Yeah, go ahead. So, getting 3x by itself?
Getting x by itself.
X by itself. And that's going to require us to move the 9y over to the other side. So we have 3x equals negative 9y plus 78. Subtract 9y from both sides to move it over. And then when we divide by 3 to get x by itself, everything kind of just works out nicely. We had x equals 3y plus 26. Okay. If you try to put it in a slope-intercept form, get y by itself, then you get a fraction. Okay. So how would you know, by looking at that equation there, how would you know that you want to get x by itself? Or what's maybe an alternate method you could use to kind of efficiently start this? Yeah. Right. We can see here that the greatest common factor of 3, 9, and 78 is 3. 3 goes into all of them. So what we could do as a first step is to divide every term by 3 before moving any of them. And that's going to eliminate that 3 in front of the x and give us x plus 3y equals 26. And then from here, I forgot my negative sign, didn't I? You were going to wait till I got further down? Appreciate it. Thank you for that. And then when we move our 3y over, we'll have x by itself, and we'll end up with the same thing that we have there. Okay? Wow. Wow. Okay. Is it complicated because of how you start, or the well, it is a lot of work. Yes. Yes. Okay. Just don't want to do it. All right, gotcha. So now that x equals negative 3y plus 26, you can take that x, plug it in for x in your second equation, and go to work with that. Okay. Any others you want to start with here? See how you start. Julia. The last one in the first row? Oh, we're not going to get through all of them, no. Okay. So for this one, x plus 4y equals 6, and 6x plus 2y equals negative 8. Which variable are we going to isolate here? Which one is going to be the most efficient? We have an x, then a 4y, then a 6x, and a 2y. Which one's going to be best for us? Gabby? The x in the top equation, right? Because that's the variable with a coefficient of 1. That's what you're looking for. And to get that x by itself, we're going to be subtracting 4y from both sides. To get x equals negative 4y plus 6. We can't combine those terms because one's got a y and one doesn't. Okay. But now that we know that x is equal to negative 4y plus 6, we can take this value, negative 4y plus 6, and plug it in for x in the second equation. So that second equation now becomes 6, but instead of x, negative 4y plus 6 plus 2y equals negative 8. Was it that far you want to go further with it, or are you good there? Yeah. Our next step here is the algebra of solving for y. And because we have parentheses, we're going to distribute 6 times negative 24y is a negative 24y. 6 times 6 is 36. And then plus 2y equals negative 8. Now, combining like terms, we have a negative 24y and a positive 2y. Putting those together gives us negative 22y. If you got negative 26y, Either you used opposite operations when you shouldn't have, because we're all on the same side here, we're just combining them, or you went the wrong direction. Negative 24 plus 2 is a negative 22, not negative 26. Okay? So two-step equation, subtract 36 from both sides. Negative 22y equals negative 44. Divide both sides by negative 22. And y equals positive 2. Since one of our equations already has x by itself, there's no reason why we wouldn't go directly there. X plus 4y equals 6. Or actually, probably this one here too. Okay, but either one you want to use, plug 2 in for y, and you're solving for x. I believe we get negative 2. Okay. Okay. Any other questions on this other than? Well, that's more of a complaint that it's too much work. But questions? Okay. Your homework is going to be to do the 4, whatever you've got left to do on this page. Okay, and we'll go over it tomorrow. Homework is to finish the page. Finish the page. Okay. All right, with gusto, folks. That's how you math.